I'm looking at numbers 22 through 25 here, where you are going to need to be able to look at an equation and state the vertical shift, amplitude, period, and phase shift. So the first thing that I did with each of these equations was I put them into standard form so that I have y equals a times the cosine of k theta plus c plus h. So for this one, there's not a lot of rearranging to do. And I can see clearly then that the vertical shift is 1. The amplitude is 4. I wouldn't state it as -4. The amplitude is the absolute value of a in the equation. So the absolute value of -4 would be 4. But if I was graphing this, I would make sure that this was a cosine that was reflected because of that negative sign. To find the period of a cosine function, it will equal 2 pi divided by k. So 2 pi divided by 1/2 is equal to 4 pi. You're taking 2 pi times 2 over 1. For the phase shift, that's equal to the opposite of c divided by k. Well, c in this equation is pi over 2, and k is 1/2. So it's the opposite of pi over 2 divided by 1/2. And then just remember, if you're simplifying this fraction, okay, to divide by 1/2, you multiply by 2 over 1. And so we end up with -1 pi, or negative pi, for the phase shift. It's the same process for the rest of these. I'll just point out that in number 24 and in number 25, notice that the vertical shift, the h value, was moved to the front of the equation instead of being tacked on at the end. And so, like in number 24 here, the vertical shift is the +2. And the amplitude is just a 1 in front of this sign. The amplitude is 1, but it would be a reflected sine curve. And then you can find the period. It's equal to 2 pi divided by k. And the phase shift is the opposite of c, so the opposite of -pi over 5 divided by 3. Remember that to divide by 3, you can instead multiply by 1/3. And so that's how we get pi over 15 here. So that's the gist. Do those for practice. Be careful that you're using pi over k for cotangent and tangent functions.